Thank you very much. Thank you very much for a bit of time this evening. So I'm going to talk about the Internet of Things and LoRaWAN. I'm Scott Andrews and I've got two hats. I work for Conway County Borough Council, which is one of the county councils here in North Wales. I've got the innovation hat, which is where I've got exposed to the IoT elements and the LoRaWAN technology. And from that, it was just so exciting. Will and I, because we both work for Conway, were like, this is just great. We also set up company Sensibility, because when we were working in the public sector, we were obviously advocating to people saying there's new technology that's gone out because they've rolled out all the connectivity. It's free for communities to use. Anyone can use it, a bedroom programmer, a business that's out there, the council themselves are using it. So we're obviously advocating it as well. And when people go, well, how do I contact anyone? And obviously there was, at that time, that was 3 years ago, there was no one to contact. And we're like, and so we realized, well, here's just an opportunity here to work across North Wales and beyond, really. So I'll be talking about the different projects we're doing. You're all here, so you know where Conway is, and we're in North Wales. And I just want to explain some the challenges we have with the topography across the authority, and this is the reason why we're using LoRaWAN, because LoRaWAN is one, because LPWAN, the low power wide area network, LoRaWAN is one of the technologies that come to LPWAN. NB-IoT is another one. NB-IoT is based on the frequencies that mobile phone networks use, but mobile phone networks notoriously have bad connectivity. We have bad connectivity in Chester, because I was there for a fantastic night out a few months ago. But you get into the rows, and you get into the pubs and the restaurants, signals goes. Signals bad in lots of rural areas. So that's why I think in Wales, the LoRaWAN is really gaining momentum. And I think a good example as well with Wales is that Wales has 5% of the UK population, but has 20% of all TV transmitters because of all the valleys and things. So that's what causes the challenges we have. The red box there represents the coastal strip. 80% of Conway's population live there. It's predominantly English speaking as a percentage. However, the total number of Welsh speakers is the same as it is in the rural area. So, there's still a lot of Welsh speakers. We also have the national park, Eryri, Snowdonia National Park, as some of you might also know it as. That covers 40% of the county. So we have challenges there as well. I was talking with someone about Betsacoed and how we have challenges there because Betsacoed's in a gorge and with connectivity there. So some pictures of the county, beaches, mountains, etc., reservoirs, and a little bit about sensibility as well. The reason why I'm doing this is because you'll see different graphics going on screen, some which are Conway and some which are sensibility, because some of the work we do in Conway pollinates an idea in sensibility, and then we can mature it, develop it, and then we also then flip it back into Conway as well. So I think it works really well. So IoT, the main thing obviously is a sensor. It's bringing you lots of information. It's hard evidence. I think that's really important when it allows you to make hard decisions. You're getting proper, empirical, accurate information that's not biased. It's not based on he said, she said, this is what's happened. And a good example of that, I've gone too far ahead in my head. We'll be going through examples of deployment. We'll be doing some ready reckoners, and we'll be doing TTN, TTI, LNS, which is the Things Network, the Things Industries LoRaWAN Network Server. So just like all parts of IT, we have an amazing raft of acronyms. So footfall. Now, this is a good example of public toilets. It might astound you to realise that public toilets are not a statutory obligation, and therefore lots of councils are looking at reviewing the provision of public conveniences with all the budget constraints that are going on. So this is data from one footfall sensor that's been relocated from the 4th of January until the 16th of January. And then, as you can quite clearly see, it was relocated on about the 17th of January and has been put in a much busier public convenience environment. When we actually zoom in on the data between the 4th of January and 16th of January, this was a rural toilet. You can actually see the time stamps that goes on, and you can actually see it was only the cleaner who was there. It was between 10 a.m. and 10:30, and you can see the person going into the gents, into the ladies, back into the gents, and then back out and gone. That's it, no one else is visiting. And during that time, the council was paying electric, water, the council has to pay business rates on public toilets because it all goes back to central government, so it becomes a big cost. And then obviously you can see the other toilets there. You can zoom in, as I said, you can see the actual timestamps, you can see when the toilet's opened, so you start to gather data when you should keep particular assets open or not. You can see it starting to round off at the top, and the footfall just naturally starts to fall off because this is in January, so it's short days. So that's footfall for a public toilet, but you could be measuring that for buildings. You might want to understand whether you've got other buildings. Should you be heating them up at a weekend or at particular days of the time? Maybe should you provide the air conditioning, make sure the ventilation's on. You could be counting people on footpaths and gates if you're a farmer or landowner. You can compare against weather data if you get other sensors in to measure rainfall and whatnot if people are going around, and compare that against historical patterns. So I'm thinking there to compare against bank holidays, maybe if you're comparing on footfall, if you're on a town centre, if you're in a retail environment, compare August bank holiday this year to August bank holiday the year before. And yes, and you can also be notified when those gates and doors, etc., have also been opened, because you can get little sensors that detect, just like a burglar alarm, that they've gone. But when they've opened, that same data can be used to tell you whether it's opened or not, but it can also be used to give you a sense of busyness overall. Sensibility, we've got a sensor on a gate at a wildlife trust. So it's not giving them accurate numbers of people, but they can just compare the number of times the gate has opened overall compared to previous times. So the weather. So this is a weather sensor we've got on the Conway Estuary. This is a fantastic piece of kit, this. It's got, I think it's 11 bits of data actually coming in off it. So we've got temperature and humidity. On the bottom there, we're still representing the temperature. It's exactly the same, but we're just visually representing it in a different way. We find this quite useful to just have a quick glance. Straight away we can see the purple, the pinky colours there. That we've got that colour there for cold. So if you're looking for a cold situation, you can just go, ignore the greens. We're just looking for the pinks, and then you can see that data. That data also works. That visual aid also works well for footfall counting or for movement as well, because you can have green for go for movement and red for stop. So you can just start to see green as in there's a person there. From the exact same sensor, we've got the barometric pressure on the top. It's also picking up precipitation, the rain, and it's picking up the solar as well, the watts per square meter. That's really good if you're looking at that over an entire year. You can see the seasonal differences, how the sun gets much weaker in the winter and the small, much lower wattage per square meter and much higher during the summer. Wind speeds as well. So to give it, and we've also got to windrows as well. I didn't even know these existed really before this project, but it allows you can see the prevalent prevailing winds for the southwesterly for the UK. You can definitely see that, but you can see all the wind speeds and the percentage of those wind speeds as well, all within just one quite clever graph. It also measures lightning strikes. Because lightning, when it strikes, it creates a very low frequency pulse, and it picks that up. And from that, it can determine roughly how far away it is. And then you can also get a sense of how many of them are actually going on as well. So you can collect general weather data, and you can compare all that data against other sites and determine if reactive work needs to happen. There, I'm thinking about if you've got a rainfall sensor. If you had a number of rainfall sensors dotted around the area, you could actually say, actually, it's rained a real lot in Conway town itself, or even Llandudno in the 1990s. Llandudno had an isolated rain shower that flooded the town, but you could actually start to have that data beforehand. I know you'd have phone calls and things on that level, but if it's a rural village, at a more central point, you can start to have that data coming in. Here we go, Storm Dara. Was it wrong order in my head? Right. So this is the weather data from Storm Dara. I'm not a meteorologist. I can't stress that enough. So if any of you are, I'm sorry if I offend any of you. But this is a pattern that I've kind of noticed on some of the big storms, is that before a big storm comes in, the temperature increases drastically. It's reaching 14 degrees at 9:30 in December. at night. It's reaching that kind of temperature. It's increased by 6 degrees. A bit later, the atmospheric pressure always drops, and you can see it absolutely plummets, and then it goes back up again. And then you also see the maximum wind speeds. Storm Dara did affect Conway quite badly. We had floods along the coastal strips towards Llanfyfechan. You might have seen in the news how Llandudno Pier had parts of its Victorian structure were wrecked by the wind. 32.1 metres per second is about 72 miles per hour. That's a gust. That's on Conway Harbour. The clue is harbour is a safe place for boats, and it's still very strong winds. So you can start to have very local weather data, and you can store it, obviously, for the long term. The OG, the original. So we now move on to different sequence of sensors now. So we've got sensors that measure distance. So the OG, this is the original level sensor that we had. You can just see there's like a sender unit on the top, and inside it's got a LiDAR sensor. So LiDAR is just it's a near laser frequency light, and all it's doing is that it bounces down the tube and it bounces back, and that time it takes is then you can then determine how far away the water is, because at the bottom of the pipe we've got a float, and obviously as the river rises, the float changes location. And that worked really well, because at the time, this was 3 years ago, there just wasn't anything else comparatively. We were just trying to think of, how can we, because we did try ultrasound, that didn't really work. We tried, because those are ones that you'll see lots of, but we tried ultrasound, you put them underneath a bridge, something like that, and as soon as you actually had really heavy rain, it would stop working. And we're like, how can we protect the sensor? And that's kind of what we came up with, and it worked quite well. It's not infallible, which you'll see in a moment. So Llanrwst, which is a town down the valley here, it's right next to the river. It likes to flood a lot, the Conway River. And you can see some blue circles there with the various centimetre. That's where we've got different sensors located around the town. And other than one, they're all still there. They're not being vandalised. Well, one of them has, but that's it. So we've got different readings coming in there that they are working, but you can see these white lines there, and that's where bits of data is missing. And that's where we started to realise there was a weakness with the LiDAR sensor, and we can't understand why. The actual sensor itself is IP67. It's meant to be weatherproof, etc. The only kind of pattern we could recognise was that if you put them in a kind of a damp, green, mossy environment, they seem to be a bit more unreliable. But even so, it didn't make complete sense. So we're just wondering if it's something to do with condensation maybe on the actual sensor itself, but I don't know. So, which is why we ended up going to the successor. So that's the Dragino unit. You saw that sender unit before, and that's called a sonde. And inside that, it's just got a sensor that all it's doing is measuring the resistance over the entire cable. And as the water pressure changes on the sonde, it's changing the resistance, the electrical resistance on the entire wire. And then from that, you get some really good readings. So this is a sensibility project, because we realised Will's dad has got a private water supply from a lake with a dam on there, and it supplies a number of houses up there. And even though the dam isn't used for its original purpose anymore, which was water power for a slate quarry, it's still a reservoir, and the reservoir has to be inspected on a 10-year cycle. So they needed some sort of sensor to measure it. So we're in a position where we're able to just try out this idea, and also we could knock the LiDAR one on the head, because we knew that it wasn't the best. So this one's been inspected by a reservoir inspector, and she was really pleased with it. She checked its calibration, and it's within 1 centimetre of her calibration tool for a £150 bit of equipment. She's getting data, or we're receiving data every 20 minutes, whilst before they were receiving data, however someone actually measures it. So it's far better than what it ever was before. And then I'm just pointing there, to the sender units at the very top. Yeah, there's the layer of the lake, and then the sender units at the top, and then you imagine this is the big cable, and then at the end there, inside the lake, you actually have the sonde. So there's a little video we've been doing on another project. So this is me just getting them out. That's the sonde. That's a 10-meter long cable. Ta-da! And that's it. That's the sender unit. Now, the advantage of the really long cable is that I know Gwynedd County Council, they had a problem with coverage trying to get the signal from one of these water pressure sensors. So they went and bought one with an extraordinarily long cable, 80 odd meters long. So they had the sonde down in a stream at the bottom of a valley, had the massive cable going up the valley until it could get to the top and just over the ridge, and then it had signal. And that's how they're now retrieving data from that. So here on this project, you've got the sender unit there on the left, and you can see the sonde unit inside a big pipe there. Now, the reason why we've got in a massive pipe, a big ugly pipe, is this stream's actually a bit crazy when it's in spate. Huge rocks come down there. So the pipe is actually there to protect the cable more than anything else, even though it's horrifically ugly, but it's only there as a temporary measure to gather data. This is for that Cardiff University project I was on about. So that's in a remote valley behind Llanfairtalherne, which is behind Abergele. This is a solar gateway we've rolled out. So this one's not connected to any electric at all. And so far, it's only been out 2 weeks, but so far that's working fantastically. I don't want to be overconfident, but I was always comfortable that it's going to succeed because there's over 1,000 of these across northern England being used by the water industry, because there are LoRaWAN sensors being used to measure, to do water meter reading automatically. And they're just gathering the data rather than sending some round every 6 months to lift up a grid and go, these are the numbers, and I've got that. And obviously because it's reading the water consumption much more regularly than what it ever did, they're now also identifying leaks on the water network before people are actually aware of them as well. So those are there. So we've tried this solar gateway and it's worked, and especially this past week we've got 100% battery. It's fantastic. It's working great. So we've rolled out many sensors there in that valley, and this is the rain. The rate is the rain on Sunday. This first peak is the rain during the daytime, and then I live on the coast in Colwyn Bay. For Colwyn Bay, there was no rain on Sunday evening. It was fine. Not so in Llanfairtalherne. As you can see, the rivers continue to build up, and it's only 20 minutes away. So our flooding team were really pleased with the data that's coming through, because as you're changing the graphs and things, it's automatically recalculating the maximums, the minimums, the averages, the average mean, the range, and the difference. It's just doing that all on the fly. You can download all of that data as a CSV. You can crunch it to as much as you want in Excel if you want to, which you might go, as IT people go, well, what's the point? You could put it into AI or whatever. But sometimes to get a project going, if you can say to someone, you can get it into Excel, people are happy. So that's that bit. So I know we were talking about the water level measuring there originally, then I've started talking about the water sonde, which uses pressure, but I want to just bring it back to the water level, to the level sensors again, because we're still using the LiDAR here. So here we're using the LiDAR sensor to measure the distance from where it is to where a vehicle is parked. This is where Snowdon is, with that. This is in the county, and we've got problems here where people are parking overnight. And obviously people are free to park, but the problem we've got is that people are parking and camping and leaving lots of litter, human waste and stuff, because there's no facilities there. It is just a lay-by. No one was doing anything with it because there was no evidence to prove that something was happening. So the community council came to us asking, well, can you help us prove that something is happening? So we came up with that idea, the LiDAR sensor. And what you can see here is the distance overall between where the sensor is and where the vehicles are parked. And you can see quite clearly there's a vehicle parked all night there, leaves very early. Vehicles parked all night over there. You can see it's midnight there, it's midnight there. And again, over there as well, it's midnight again. So we've got evidence that people are parking overnight. Compared to like there, which is maybe what a lay-by is there for, is just for someone to stop, have a cup of tea, enjoy the space, enjoy the countryside, look at the view. So that evidence provided to the community council. I don't know the outcome of that, but technically that was a success. The political element is beyond my control. So I'm just showing you there how you can measure the distance of something. There's vertical, rivers, streams, silos, and slurry pits. And the horizontal, which we've talked about there, I was thinking now, delivery vehicles, notification of returned vehicles. So you could put that LiDAR sensor at the back of a parking space, and then if make sure that a vehicle's parked in that parking space, then you know that vehicle AYZ has come back. Notify when something strange out of normal patterns happens. And again, you compare it against historical patterns. So thinking about the parking in remote areas, do we have a bigger incidence during the summer? Of course, you would expect that to happen. That's an easy example, but that's what you might want to compare it against. Temperatures of a space, a room, a workshop, or a barn. I need this one as a prop in a moment. So this is a temperature sensor of a library. A library particularly because you can see libraries are open 6 days a week. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So you can see the temperature going up. You can see the 3 days it was open over Christmas, between the Christmas and New Year breaks. So you can start to identify when buildings are actually open or not. When the temperature has actually gone too high. Since I've been on these projects, I do notice on school holidays or national holidays when if I see the plumes of smoke coming out of boilers and things, and I'm like, oh, it's a school break, that shouldn't happen. Stuff it makes you much more aware of it. But you can have all those automatic alerts. And so exactly the same thing on a much bigger scale. This is the large office building in Colwyn Bay that Conway Council's got. So you can see Monday, Tuesday, Wednesday, Thursday, Friday, and then the weekend, and then Monday, Tuesday, Wednesday. So we could just have lots of sensors over the entire office building, all relaying back to one gateway. And because they're mobile, you can just go move them around if you need to. So just explaining, so you can measure the temperature of buildings and schools. Landlord properties, that's a massive thing as well, because obviously the mold, there was that court case where a little boy died. So as a result of that case, there is a responsibility on landlords to make sure that properties are appropriately, or they don't have too much mold, and an easy way of doing that is by making sure it's heated appropriately. You can get additional sensors as well that detect volatile organic compounds as well, so that's the mold spores in the air. You can get that. Hotels. The hotels one, because you could have the temperature sensors. You can also have LoRaWAN TRVs, the thermostatic radiator valves. And because you can send commands down to a radiator valve, you can have the temperature being read in a room. And then when it's, say if it's a B&B, when normally there's not people there between 10 a.m. and maybe 4 p.m., you could turn the TRVs down remotely, and then maybe turn them on again, ready at 4 p.m., ready for when guests are going to come back, ready. Obviously you're incurring costs again there. Temperature sensors can be used for water pipes, so you can have the automatic recording of Legionella, for your Legionella records, I should say, not for Legionella, it's not detecting Legionella. But the fact you're then measuring temperature change means that you're proving the water has flowed, you're making sure the water has reached temperature. If the water isn't changing temperature, you're proving the water hasn't flowed, then you can start to say, well, why hasn't it flowed? Because that could cause issues in itself as well. Just the room temperature remotely, I've said. And this is the key thing as well. You can place all the data into some sort of big, massive dashboard. This is not like just a Wi-Fi or a Zigbee matter frequency thing, maybe covering your house, where you may be looking at it on your phone and go, oh, I know the temperature in all my rooms. This can be scaled for like Premier Inn, or it could be for a hotel chain or supermarkets to monitor their warehouses and things. And one person in one room on one computer screen can go in, I can see my domain. But they can see everything there in one central view. So we've worked in sensibility with a farm to measure the temperature in their vaccine fridge. So you can see, particularly when they move the sensor from just their storeroom into the fridge, that they've kept the vaccine in a stable environment. And therefore, if sheep start to still be ill, even though after they've administered the medicine, it means they can claim against insurance with more conviction because they've got the evidence to prove they have kept the medicine in a stable environment. Whilst before, apparently, the insurance companies would say, well, how can you prove you've kept the vaccine in a good environment? That can also work in the pharmaceutical environment as well. So we've talked about measuring temperature and hospitality, catering, medicine. Don't forget it can work with temperature-controlled logistics, and that's where I need another prop. So this is a LoRaWAN sensor. It's just a label, but that one it allows tracking for like a package maybe, or a big trolley or a crate or something. But that also measures temperature as well. So if you've got like a crate of something that needs to be transferred somewhere, then you can keep tabs on it, literally, and know the temperature of it, and it can just move around. You've got all the automatic record keeping. You're not relying on a person to do that. Don't forget, people cost money. People are going to cost more money from April, the NI contributions and things. So, there's other smarter ways of working. You receive notifications on alerts, sausage meat saved. That's an example where we worked with sensibility with a cafe, where because they had the temperature records, a fridge had failed. But because he had the temperature records, he knew that the temperature was safe in the fridge. He was saying that normally he'd just write the sausage meat off because he couldn't take the risk. So he saved £500 just to the sausage meats there again. Another worked example there is in Conway. There was an educational establishment where a child was very poorly after visiting, and the parent was alleging food poisoning. No other child was sick, but that didn't matter. This parent was like full at it and was saying, you're not keeping and monitoring your fridges and freezers. We were able to provide the temperature from our fridges and freezers and prove unequivocally this is what the records were, and that just died to death. Nothing more happened of it. I'm not saying it would have prevented any like litigation things, but it meant that someone wasn't bogged down in lots of paperwork and fending it off. It was just, here's some data, and it just went away then. So the temperatures, this is just to show how it's all changed in the few years this has gone on. So we've had temperature probes. This is where we start off with the fridges and freezers, where we'd have that sender unit maybe on one central fridge, and then we'd have a probe going into each of the fridges, and that's what we're doing originally. And that was a bit clunky. You needed to drill holes, maybe you needed to get a refrigeration engineer in. It was a bit tricky. And then you went on to these other ones as well. But you start having wires, and it gets a bit clunky as well. And then these other sensors came out, and these are good. These allow you to, these can work in freezers and the food safety grade and everything like that. And so they've got good battery life. But then now they're coming out with the kind of Kindle screens. So these are working really well. We find finding this with sensibility. We've got them working in some butchers, and we've got them in an agricultural wholesalers, because people can see the screen there. The non-techie people can go, that's what the temperature is. But then the managers also know that's what the temperature is, because it's automatically being recorded. So you're not having to have differences, different data sets. And I'm conscious I've been looking at the screen quite a bit, and I apologise, but I'm going to look at it even more now whilst I go through the LoRa handy checker. So when we're sending out data from these, they use a spread factor, because they use this context of chirps for sending out data from them when they send out on the radio frequency. Spread factor 7 is your best environment. So when you hear these things saying, 10-year lifespan, that's when the sensor is sending data out at spread factor 7. Spread factor 12, you don't want, but sometimes that's your fail-safe. But that has the lowest data capacity. We've had a sensor which could send temperature, humidity, barometric pressure, nitrous oxide and things. But because it was working on spread factor 12, it was having to send 2 data chirps, because all of that data wouldn't fit on one chirp, which meant it was sending 2 data chirps, and then it was just eating the battery even more. That was just a lesson learnt, really. So spread factor 12, is data rate 0. So I just remember that as 0, as in you don't want it, and work out from that. And so we're working on the free spectrum that Ofcom let you have, and roughly under the licensing terms, even though it's free, is that spread factor 12 is allowed up to 1.5 seconds to spread out. And then you can just halve it in the licensing spectrum. These are, as I say, ready reckoners. But you can start to see how spread factor 7 has only got 50 milliseconds of time. So it's really fast. It's like, that's it, the data's gone, while spread factor 12, and it's just takes longer to send the data. So at spread factor 12, under the free licensing, you end up being allowed to only send that data once every 80 minutes, which might not be very good enough, especially when we've talked about the flood sensors and protecting communities, or your fridge maybe. So you can start to see, you just halve it. Again, Ready Reckoner, I think the number is actually something like 1 minute and 40 seconds or something for spread factor 7. But if you just kind of work on these half cycles, then you start to get a real feel for what it's capable of. And you start to see that if you have it at spread factor 7, you can send data far more frequently, and you are protecting the battery life as well. And that's what I've banged on about the battery life there. Right. So, spread factor. It's spread factor 7. If you're sending data every 20 minutes, expected battery life, manufacturers tell us 10 years. I would say that's a non-complicated sensor, like a temperature or humidity sensor. It's just basic electronics inside, really. But also the water pressure sensor, we're expecting 10 years out of that. So just to keep it all simple, spread factor 7 at 10 minutes. Instead of 10 years, we're now we're expecting it for 5 years. You just simple maths. Then spread factor 8, because remember how they spend longer on air compared to spread factor 7. If you're sending that every 10 minutes, that's 2.5 years. And spread factor 8 at 20 minutes becomes 5 years. Yeah, so it's just halving and timesing by 2. That's all you're doing. Spread factor 8 is 40 minutes. And you coming up to 10 years. So a good example here is a soil moisture sensor. We've worked on a project in Llandudno where there's actually a lot of metal in the way, and it's affecting the radio signal quite a lot. But soil moisture sensors, even if it absolutely chucks it down, it doesn't make a huge difference about knowing the soil moisture every 20 minutes. But it is useful to maybe know it 4 times a day type thing. So you just change how often that data comes through, and then you change your battery life as appropriate for your project. So spread factor 8, 20 years, I think your hardware would fail at that point. But we'll just we'll get into the big spread factors now. And here's where I'm talking about spread factor 12, 80 minutes. Look at that, instead of 10 years, you start looking at 1.25 years, spread factor 12. Say if you do want the data more frequently, it's half a year, spread factor 12, you start down to a third of a year. So you'll be going, so quick summary, spread factor 12, 11, and 10 are bad. We've touched on how the water industry is using LoRaWAN a lot already in Northern England. They're going for about spread factor 9. I think they're getting data about once every hour, I think it was. The adaptive data rate, so that's the system behind the scenes that your LNS, your LoRaWAN network server does. The adaptive data rate is what's telling the sensor, or confirms with the sensor, what kind of spread factor it should be working at. The great thing is that the sensor, if it doesn't receive a downlink from the gateway on every 20 pulses, it'll say, right, I'll increase my amplitude. Oh, I was on spread factor 7, no one's hearing me anymore, I'll move up to spread factor 8. And then if that doesn't work, then it'll go to spread factor 9 until eventually it is heard and it'll go, fine, I'll now work on spread factor 9. So you can gather that data set as well, because you might want, for a particular project, keep everything at spread factor 7 for all the benefits I've talked about there. Or maybe you might say, well, it's in such a rural location, or the terrain is so challenging, I'm quite happy for that one to come in at spread factor 10. That's just the way it is, and I'm prepared to take that. So all the ADR works on is by the signal noise ratio, basically, but the LoRaWAN network server does all that for you. And that's what I'm saying, LoRaWAN sensors can receive data. After they send, it listens just to see if there's what's called a downlink to tell it to give it some instructions. So you can change how often they send. So you might think that 20 minutes is good enough for a water pressure sensor. Then you might say, no, actually I want data every 10 minutes, or no, I only want it once an hour. You can adjust that remotely as well once they're in situ. The LNS, as I've just said, it receives the data. and it confirms what the preferred spread factor would be for a sensor. And it allows adjustment as the environment changes. As you're putting gateways in, or you're just putting in loads of metal, you put a load of scaffolding around, then the sensor would be wanting to go onto a different spread factor, a higher spread factor. And this is an important point. Gateways, they send downlinks. It's not duplex, so that means they stop listening. But even though I'm saying that, that's changing this year. I know there's some gateways coming out from Multitech and RAC Wireless that are now starting to become full duplex. So that's all still changing all the time. But I think the main thing is there's just an argument for more gateways overall, if you want coverage, if that's what you want, and battery life. So ttmmapper.org, this is the website that shows you the gateways that are on the open kind of community version of the Things network. That's red squares, roughly Conway County. Gwynedd have got a few, and if you look on the All Wales one, there's loads in Powys, and which is like the big central strip of Wales, and then there's loads down in Carmarthenshire and Ceredigion, they're on the west coast of Wales. There's a huge gap in the Midlands, but Norfolk and Suffolk, they've gone crackers with it. It's on everywhere. They've got gateways on fire stations, on schools, libraries, the whole lot. So they've really embraced it. So it's an open network, anyone can use it. There's no communication costs, there's no SIMs on those. The only communication costs are in the actual gateway, whether you connect that via Ethernet and SIMs and things. There's no Wi-Fi limitations, as I've spoken with some. There's up to 8 kilometers in rural locations, 1 or 2 kilometers in urban environments is good. The sensors, as we talked about, up to 5 to 10 year battery life, subject to radio environment. And some buildings, localities need additional gateways. A good example there is in sensibility. We've got a customer who's a butcher. So the butcher has got a freezer, that's a walk-in freezer, that's inside a walk-in fridge. The walk-in fridge is inside a building with the metal shutters on it. Outside the building is a metal palisade fence next door to the railway, and just beyond the car park is a huge Vodafone O2 metal mast. When the shutters go down, it's like a Faraday cage. There's nothing comes out of that. Put a gateway inside the building, it's all good. Even getting through the double skins of the walk-in fridges and freezers. So just some pictures of some gateways, because this is an internal gateway. There are different manufacturers, but they just look for a broadband router size, really. But you get external gateways on schools, which is what we've done mainly in Conway. Because it covers communities. In large towns, you have more schools, and it covers multiple sites. So they're on a managed network infrastructure, which keeps the running costs down. We don't have the SIMs and things in the council. And as a local authority, the local authority has a good bit of planning law, where this bit of law treats it the same as a drinking fountain or an animal trough. So it's allowed to go in as a benefit for the community. So it's allowed to go in. That's local authorities only. And as I say, that's the law applies to Wales. It was grandfathered in at devolution from England, but you need to check for your own specific areas. But that's if you need to work with the local authority. And if you're working on a commercial area, you've got different laws that apply again. The joy. And, oh yes, so lighting columns we've used in Conway. They work well. Notice how we've changed this gateway. It was originally fitted on the left-hand side. It was fitted low down. That affected the radio signal. So we made the electrical engineers go back, and they fitted it at the very top of the pole to make sure we got good signal. But excuse me. But you could put it on a folding column as well. So I'm trying to think, if you've got, I don't know who you might work for, but you might work for a large retail environment that might have a massive warehouse or a huge car park. You don't just have to think about the building. You could put them on lighting columns in the car parks or anything like that. And in Conway, because we're trying to keep software costs down, we've used some software that's open source called WSO2 that takes webhooks from the LNS, from the TTN. It acts as a broker, and it pumps all the data into our database backend. We use now Microsoft SQL there, because it's already licensed in Conway. And So we're storing all the data, because I keep on saying sensors, and that's wrong of me. It's more accurate to call that a node, because this has got a temperature sensor there. It's got a humidity sensor in there. I talked about that weather sensor is wrong. It's a weather node. On it, it has a temperature sensor, it has a humidity sensor, it has a barometric pressure, it has a solar sensor. Oh yeah, and we can monitor thresholds for send messages out via email, SMS, and Teams alerts. We touched about on the AI side of things. In sensibility, we've done where you have a threshold, but what we're doing now, we then send like the previous 4 hours that have happened at that threshold trigger, send it to OpenAI and go and send a synopsis of this data, and then we send the message on to the client via WhatsApp. So it means the client isn't just going, oh, the fridge has reached 8 degrees, it's the end of the world. They've got some data there to determine what might be the issue. Has it just spiked at 8 degrees, it's a one-off, and therefore maybe assume the door's been left open, or can you see that that the temperature's been incrementing slowly? You got therefore implying maybe a broken down fridge. And obviously you could then integrate it with automatic voice calling and stuff like that. And then Packet Broker is just approaching the end. So mention about TTN, which is the free open source community, LoRaWAN community. Repeated some words there. But TTI is like the commercial one. So TTI allows you to start to have support on the gateways, and you can buy that. You can also start to block traffic. So say if you didn't want to relay certain amounts of traffic, you can actually start to block it and say, no, I only want to receive the data from my sensors on my gateways, and that's it, and I'm not going to do anything on that. But we haven't done that. And when you've seen some of the images there, we've used Grafana. Sorry, a bit fast there. We've used Grafana in the County Council because it's open source software. It's a steep learning curve. It's got amazing flexibility. It's always being updated. And we're presenting that to internal staff, externally for public environment, and for schools as well, because we're talking about STEM data. You're presenting all of it. And the data security is one other thing that people always talk about. It's all encrypted. It's tiny amounts of data, and I think most of the value is only in context. If I have this in someone's bedroom, for example, it's 18 degrees. But I don't know where that sensor is, because with that amount of data is just too much. All we're sending is the temperature and humidity. It's only when you know that this asset tag is in Scott Andrews' house that it starts to have that additional richness and value. But if someone intercepts that data, it has no context. It doesn't mean anything. And I think that's another good advantage of LoRaWAN as well, because the amount of data you can fit on a packet of data is so small. It's GDPR compliant. You can't send faces, you can't send voices or anything like that. So these were projects we were saying about for the future in Conway, fridge temperatures for food safety, where we've got the evidence fridges. We're already doing that. The river level monitoring for NFM, we are now doing that. Social services, we are working through that at the moment. The assisted living scenarios, we are working through that at the moment. The CO2 levels in schools to monitor fresh air and make sure that the air is turning around and rotating, we have done that. Footfall counting in libraries, we are doing that. So that was like an aspirational list, and we're just doing it. So it's all good. Finn, there we go. Thank you very much.